All right, welcome to limits. What we're going to do today is determine whether or not a limit exists, and we're going to do that by using two different tests. One, as we talk about the limit of f of x as it approaches from the negative side and as it approaches from the right side. So it can be a very simple concept as long as we understand that when I talk about the limit as x approaches a from the negative, that we are approaching from the left and going right. And when I talk about the limit of f of x as x approaches a from the positive, that we are starting on the right and going left. If you understand that concept, you're going to do great. Okay. The second part is the idea that the limit has to exist only if those two values are the same. All right. So let's just dive in. We'll look at a couple examples and you'll be able to figure this out. All right, so we want to figure out the limit of f of x as x approaches 1 from the negative side. All right, so here is 1. Okay, so if I am approaching from the left, it looks as though f of x is approaching a y value of 1. So therefore, I say 1. If I talk about the limit of x as it again approaches 1 in terms of the x value, from the positive side, it looks like as I approach from the positive side, as I go from right to left, it is approaching a y value of 3. Now, since these two numbers are not the same, then that means the limit of f of x as x approaches 1 does not exist. All right, so those two numbers have to be the same for it to exist. All right, let's look at another example. Okay, so I want to find the limit of f of x as x approaches 2 from the negative side. All right, so here's 2. So as I approach 2 from the negative side, it looks like I get a y value of 3. As I approach 2 from the positive side, okay, it looks like I'm also getting a y value of 3. And since these are both the same, the limit of f of x as x approaches 2 is 3. Okay, so simply put, the two limits have to be the same for it to exist. If they're not, it does not exist. All right, so a little bit more practice here, but this time we'll do it with true and false. All right, so this one does not have a positive or negative, so that means I have to check it from both sides. So the limit of f of x as x approaches 1 from the left and from the right, it looks like it exists, but it looks like it's a value of 3 and not 1, so therefore that's false. So the limit of f of x as x approaches 1, we just figured out, is 3, so therefore we would say it's true because it says it's 3. Now, does the limit of f of x as x approaches 1 exist? And I am going to say true, and the reason is because as I approach from the left and as I approach from the right, I am approaching the same value, so therefore it exists. All right, so now I'm looking at negative 4. So if I go over here to negative 4, it looks like as I approach from the negative side, I get a 1. And as I approach from the positive side, I get a negative 2. So therefore, they're not equal to each other, so I'm going to say that this is false. All right, the limit of f of x as x approaches c, and c is any value from negative 2 to 2. All right, so just cleaning this up real quick. All right, so they want us to look at any value from a negative 2 all the way to 2. Well, I do not see any breaks in the graph. Remember that this point does not matter because we already tested the limit of f of x as x approaches 1. So it looks like from a 2 to a negative 2, it's continuous. There's no breaks there, so therefore I am going to say that it is true. It exists. All right, last example here is basically we have to just create our own graph, and then we're going to do the same thing that we've been doing. So this is just a quick reminder on how to do our piecewise graphs. All right, so I got to do y is equal to x minus 3 when x is less than 1. So y-intercept is -3, slope is 1, so therefore -3 is here. I have a slope of +1, and then I end when I get to 1. And since I want less than, I'm going to use an open. All right, y is equal to a value of 2 when x is equal to 1. So they're basically saying that you have the point 1, 2. So 1, 2 is right there. All right, and then y is equal to x squared plus 1 when x is greater than 1. Well, technically I would use an open. Notice that if I plug in a 1 here, 1 squared plus 1 is 2. I would use an open here, but it's already closed, so therefore I just have this solid point. And then if I plug in a 2, it looks like I get a 5, and then it's going to be a curve because of the quadratic. All right, so I have this graph going on. All right, so now what I got to do is part B. So I got to figure out the limit of f of x as x approaches an a value. The a value they want me to use is 1 from the negative side. All right, so if I do a little test here, as I approach 1 from the negative side, it looks like I'm getting to a y value of -2. Okay, and if I approach, so now if I'm going to do the limit of f of x as x approaches 1 from the positive side, it looks as though I am getting to a +2. And since these two values are not the same, when I go to do the last part, if I want to figure out does the limit of f of x as x approaches 1 exist, I am going to say that it does not exist because these two values are not the same. Okay, so big idea. Make sure you understand that the negative means coming from the left, positive means coming from the right. They have to come to the same point in order for it to exist.